Right, construction vehicle had a container of mass 80 kg, which was left stationary on a frictionless floor. The vehicle exerted a force of 4.5 kilonewtons over 3 times 10 to the power negative 2 seconds on the container. The collision between the vehicle and the container was inelastic. 15.1, explain the concept inelastic collision there. Okay, now for 15.1, inelastic collision is a collision where momentum is conserved, but kinetic energy is not conserved. There, if you got that, 2 marks for that there. And define the term net force in terms of momentum. This is Newton's second law in terms of momentum. It says that the net force acting on an object is equal to, define the term net force. The net force is equal to, the net force acting on an object is equal to, the rate of change in momentum in the direction of the net force there. So the net force is equal to the rate of change in momentum in the direction of the net force. That is defining the net force in terms of momentum there, which is also known as the Newton's second law in terms of momentum there. 15.3, calculate the velocity of the container after collision. So we want to calculate the final velocity there, and it was knocked from being stationary, meaning that initially it was at a velocity of 0 there. So we are told that the net force is equal to 4.5 kilonewtons, which we must multiply by 1,000 there to convert that kilo into newtons there. It's going to give us 4,500 newtons there when you multiply them. And we have a contact time of 3 times 10 to the power of negative 2 seconds there. So what do we do with this information here? We are going to be applying impulse, product of net force and time being equal to change in momentum, although usually in most cases we'll be calculating change in momentum first and then calculating and then dealing with the force after. But in this case here, we must first calculate the change in momentum and then go to velocities there, because what we need to calculate is the final velocity of the container there. So we start here. We say that the product of a net force and the time, the impulse there, which is equal to change in momentum, will be equal to, we have a force of 4,500 there, multiplied by a time of 3 times 10 to the power of negative 2 there. Calculate the time. We have 4,500 multiplied by 3 times 10 to the power of negative 2 there, and it gives us a 135 Newton second there. Those are the units that we're going to be using. They come from the fact that we are multiplying force and time, so it's going to be units of force multiplied by the units of time, so it will be Newton second to them, which is equivalent to kg meters per second there. And now we have impulse, but we know that impulse is equal to change in momentum. So we say that change in momentum, which is going to be a mass velocity final minus velocity initial. We're going to choose a positive direction, so a container that is struck by a vehicle that is moving forward. We simply just choose forward, the direction of the force as positive. The direction in which the container is experiencing the force is the direction that we choose as positive. And then from the perspective, from the point of view of the container, that is simply just forward there. As we do not have a sketch there to have left or right there, just forward. So we have a change in momentum of 135 there is equal to a mass of 80, a final velocity that is unknown minus an initial velocity of 0 there because it was stationary. So we have 135 equal to 80 mass, and then final velocity there, Vf minus 0 is just simply just Vf there. So divide here by 80, divide here by 80, and the final velocity there is going to be 135 divided by 80. giving us a 1,609 there, 1,69 meters per second there, forward there, and the direction of the force there. Right. So for this one, we have 4 marks there. So it's going to be 1 mark for calculating the impulse there, and then 2 marks for calculating the velocity there. So the gist of this question here is the fact that impulse, the product of a net force and the time, is equal to the change in momentum. So we have the force and the time, so we can calculate the impulse. Once we have the impulse, then we can say that this impulse is equal to the change in momentum. We can substitute that impulse of 135 under change in momentum. We have a mass of 80. We are solving for final velocity and initial velocity of 0 because it was stationary before it was knocked off. So and then we solve from there. From there. So the key thing here was knowing that impulse is equal to change in momentum. Once we have calculated the impulse, then we have the change in momentum from that there. Okay.